So this question, we're given h of x is negative 3x plus 3 over x squared plus 6x plus 8. We want to find the domain. We want to find vertical asymptotes, horizontal asymptotes, slant asymptotes, X-intercepts, and the Y-intercept for this function. So let's start with the domain. We have to remember that you cannot divide by 0. So to identify the domain, we're going to look at the denominator and find out when does it equal 0. So I'll ask myself, when does x squared plus 6x plus 8 equal 0? And I'll answer that by factoring. You could use completing the square. You could use the quadratic formula. X squared 8 plus 6x, so that's x times x plus 4 times plus 2. We get plus 4x here and plus 2x there. So x plus 4 times x plus 2. So when does that equal 0? Well, that would be x plus 4 is 0 or x plus 2 is 0. So that'll give us x is negative 4 or x is negative 2. Those need to be removed from our domain. So here's negative 4, here's negative 2. Remove those points because they make the denominator equal to 0. So my domain includes everything else from there to infinity, in the middle, there to infinity. So if we're going to do that in interval notation, we would say negative infinity to negative 4 union, negative 4 to negative 2 union, negative 2 to infinity. That's our domain. Now that's a good start for us to figure out the vertical asymptotes. So what have we done? We've factored the bottom. So currently I have h of x is negative 3x plus 3 over x plus 4 times x plus 2. So we're going to use that to determine the vertical asymptotes next. So let's do that. H of x equals negative 3x plus 3 over x plus 4x plus 2. And I want to factor the top. So I'm going to factor out a negative 3. What does that leave me with? X minus 1. 3 divided by negative 3 is negative 1 over x plus 4, x plus 2. And as we said on the previous page, if the bottom is 0, the function is not defined at those values. We had to remove them from the domain, but that will also help define our vertical asymptotes as long as they don't divide out. X plus 4 does not divide out, x plus 2 does not divide out. So to get my vertical asymptotes, what am I going to say? Well, when is x plus 4 equal to 0? When is x plus 2 equal to 0? So we get x equals negative 4. We get x equals negative 2. Those should be my vertical asymptotes. Now, how about the horizontal asymptotes? To do that, I'm going to go back to my original version of this, multiplying in the x plus 4, x plus 2. My original version was negative 3x plus 3 over x squared plus 6x plus 8. And what do you notice? The degree of the bottom, the highest power of the bottom is 2. The degree of the top, the highest power of the top is 1. So the bottom is growing a whole lot faster than the top. In the way I like to think about this, I think of x about 1,000. 1,000 squared is 1,000,000. So as far as 1,000,000 is concerned, 6,008 is irrelevant. So downstairs it's basically 1,000,000. Upstairs it's basically negative 3,000. That's a very small number. So as x gets large, negative 3x over x squared behaves like negative 3 over x. And as x gets large, negative 3 over x gets closer and closer and closer to 0. So the function heads to 0. If the degree of the bottom is bigger than the degree of the top, the horizontal asymptote is always going to be the y-axis. Check that, x-axis. The x-axis will be the horizontal asymptote. And what's the equation of the x-axis? The y values tend to 0. Y equals 0. Now, how about slant asymptotes? The degree of the top is 1, the degree of the bottom is 2. You have a slant asymptote if the top is 1 more than the bottom. That is not the case here. The top is 1 less than the bottom. So we conclude here that there is no slant asymptote. Now our next thing to do is to find our intercepts. So let's do that. And I'm going to stick with my factored version of that original function. And I will say h of x is -3 times x minus 1 over x plus 4, x plus 2. And I want to find the y-intercept. What is the y-intercept? That's the value when x is 0 solving for y, so that's h of 0. Plug in 0 for x and see what the corresponding y value is. So that's -3 times 0 minus 1 over 0 plus 4 times 0 plus 2. So -3 times -1 over 4 times 2. That's 3/8, or 0.375. So our y-intercept in point form, the x value is 0, the y value is 3/8. So we'll look on the graph shortly to see if that's correct. And then how about the x-intercept? To get the x-intercept, set y equal to 0 and solve for x. Well, if I said y equals 0, y is the h of x, so 0 equals -3 times x minus 1 over x plus 4, x plus 2. When is a fraction equal to 0? A fraction is equal to 0 when the top is equal to 0 and the bottom isn't, but nothing cancels, so that's not an issue. So when is the top equal to 0? When does -3 times x minus 1 equal 0? Well, when x minus 1 equals 0, when x equals 1. So if x equals 1 and y equals 0, we get our x-intercept. Our x-intercept is 1, 0, is the x-intercept. Only one of them. So we found our domain, we found our asymptotes, we found our intercepts. So let's take a look at Desmos and see if all of that looks correct. So we go all the way back to the beginning. My original function was -3x plus 3 over x squared plus 6x plus 8. Let's look at it. H of x equals upstairs, -3x plus 3 divided by downstairs, x squared plus 6x plus 8. Interesting. Now, what did I say my vertical asymptotes were? Well, we had x equals -4. Okay, maybe. And I had x equals -2. Again, maybe. Make them look like asymptotes, make them dotted lines of the same color. But I don't see what's happening in between. Remember, we said for the domain, we removed -2 and -4, so I feel good about that, but what's in between? If I move upwards, whoops. If I move upwards, do I see anything there? No, if I move downwards, do I see anything? Ah, there we go. So indeed, those values between -4 and -2 are in the function. They're just difficult to see in this window. When I zoom it out, now I can see it better. So the two vertical asymptotes look pretty good. Now, how about the horizontal asymptote? Let me go back to this window so I can see it. What did I say it was? Remember, the degree of the bottom was bigger than the degree of the top. When that happens, we say the horizontal asymptote is the x-axis, which is the line y equals 0. Now, can you see as we move to infinity, this function, this green function, it gets closer and closer to the red line, y equals 0 in both directions. So that makes me feel pretty good about it. Notice that it intersects the asymptote, which can happen. Some students don't think that's possible. Indeed it does, and that's going to be important for us because we also talked about the intercepts, and we said 1, 0 was the X-intercept, and sure enough, it's there. And what did we say the Y-intercept was? I think we said it was at 3/8. As a decimal point, right, 3/8 is 0.375. So again, there's our X-intercept. Our Y-intercept is here. What is that? Great. That's 0 and 0.375 or 0.3/8. So our X and Y-intercept look good. They look like the only intercepts. Our vertical asymptotes look good. Our horizontal asymptotes look good. And our domain, again, is everything, because again, in the middle there, you've got to see, we have values way down there, right? The function is defined between -4 and -2. So our domain includes everything except -4 and -2.